Metric students, welcome back in today's video. Today we are going to be looking at physical sciences. Okay, yes, specifically in the question paper that was written in November 2014. Okay guys, mind you something. Whenever you practicing your question papers, okay, maybe you're practicing it for Feb, March or June, it doesn't necessarily need for you to practice Feb or June question papers. Okay, yes, maybe if ever you're writing at Feb or March, it doesn't necessarily need for you to use Feb question papers. Okay, yes, so mostly in most times you should use September, you should use December, you should use June. Okay, yes, so that at least you might find something similar. Okay, yes, so again, in today's video we're going to be looking critically on our Newton's law. Okay, on Newton's second law calculations again. Okay, using this question paper. Okay, in this video, this is whereby we're looking again in two blocks. Okay, yes, which are moving vertically. Okay, yes, are connected along a pulley. Okay, yes. Okay, yes, guys, please don't forget to subscribe. Please, thank you so much to those who have subscribed. Okay, yes, please don't forget to subscribe for more content, for your more lesson academic content. Okay, yes, let's get into the topic. Okay, so we have this scenario here, our question paper 2014 November, physical science in the side of physics. Question 2 says 2 blocks of masses. Okay, yes, so this scenario here, so sorry. Okay, so 2 blocks of masses 20 kg and 5 kg respectively are connected by a light inaccessible string P. Okay, yes, so by this inaccessible string P, which is also said to be as our tension 1. Okay, yes, so a second light inextensible string Q. Okay, our string 2. Okay, yes, attached to the 5 kg block runs over a light frictionless pulley. Okay, so it runs through here, as you can see. Yes, so a constant horizontal force of 250 newtons pulls the second string, as shown in the diagram below. The magnitude of the tension in P and Q at T1 and T2, as I already explained. So for Q, the magnitude of the tension acting on Q, on that string Q, it's T2, and the tension that is acting on the string, that is P, that at P is T1. Yeah, so the magnitude of the tension in P, okay, yes, ignore the effects of F friction. Okay, so meaning that the pulley is frictionless, there's no friction acting on the pulley. Yes, so meaning that the rope or the string, yes, the string, it's moving or it runs through the pulley smoothly, yes, frictionlessly. Okay, so the very first question, okay, let's jump to the very first question. So the very first question says state Newton's second law of motion in words. Okay guys, mind you, Newton's second law of motion is going to be asked, okay, yes, in each and every time in your exams. Okay, yes, you should know, you must know your Newton's first law, your Newton's second law, and your Newton's third law as well. Okay, yes, so this basically means here that we have to state Newton's law of motion in words. Okay, yes, so our 2.1, our answer for 2.1 is Newton's law. Okay, so sorry. So our 2.1, our answer for 2.1 is Newton's law. Okay, so sorry. Newton's law, Newton's second law, so sorry. Newton's second law states that when a net force, okay, or a net force is applied on an object, the object will accelerate, the object will accelerate in the direction of the net force Okay, so Newton's second law of motion states that when a net force is applied on an object, the object will accelerate in the direction of the net force. Then the acceleration, meaning that is directly proportional to this net force, okay, to the net force, and inversely, so sorry, there's supposed to be R, inversely proportional to the mass of an object. Okay, yes. So Newton's second law states that when a net force is applied on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Okay, that's how it goes. So let's jump to question 2.2. Yes, so let's jump to question 2.2. Okay, our question 2.2 says, draw a labeled free body diagram indicating all forces acting on the 5 kg block. Okay, so now we're going to be looking at our 5 kg block. Okay, yes, let me rub there. Okay, so we're going to be looking at our 5 kg block. Okay, yes, what are forces acting on this 5 kg block? You can see that there is a tension that is acting upwards. Okay, yes, that is pulling the 5 kg block, and also you can see that there's also another tension that is pulling this 5 kg block, which is T1. Okay, yes, again there is gravity acting on it because it's moving vertically, meaning that the gravity is acting downwards. Okay, yes, so let me erase that, okay, so that you can see clearly and look again. Okay, so this is whereby we have, okay, your dot must be quite bigger in case, again, okay, in case there are forces acting on the same direction or to the same direction, okay, from the object. Okay, so this is whereby we have, okay, your dot must be quite bigger in case, again, okay, in case there are forces acting on the same direction or to the same direction, okay, from the object. Okay, So we have, this is a 5 kg block, okay, yes. So we said we have force that is acting upwards, okay, yes, force that is acting upwards, which is the tension, which is T2, okay, that is applied there, okay, yes, this is our T2, okay, yes, this is our T2, this is our tension, and then this is our tension force, and then we have again T1, okay, the other tension force, okay, yes, which is have a smaller magnitude than T2, okay, yes, this is T1, which is a smaller magnitude, okay. So okay, we have gravitational force acting downwards, okay, we have a gravitational force acting downwards, okay, yes. So in this is the free body diagram for the 5 kg block, okay, yes, okay, moving guys. So let's move to question 2.3. So question 2.3 says calculate the magnitude of the tension T1 in string P. Okay, so we're required to calculate the tension that is acting here, okay, yes, and mind you, the tension that is acting here, okay, on this 5 kg block, okay, which is T1, and here in that 20 kg block is the same, okay, yes. And now let's go back to our question. So our question says calculate the magnitude of the tension T1, okay, the tension T1 in string P. Okay, so you can see that those two objects, or I can say that tension which is T1, which is at P, is acting between those two particular blocks, block 5 kg and 20 kg. So it's easy for us to determine this and calculate. So let's calculate it. The 5 kg block is connected with the very same string with 20 kg block, meaning that the tension is the same. Okay, so we're going to say for the 5 kg for the 5 kg block, our net force is equal to mass multiplied by acceleration. So what are net forces that are acting there on our 5 kg block? We already presented there. So we have T2, okay, we have T2, okay, yes, the tension force that is pulling those two blocks upwards, or I can say that is pulling, I mean 5 kg block upwards, so sorry, T2, which is pulling 5 kg block upwards, which is also known as the applied force, okay, yes, constant force that's acting horizontally, okay, T2, okay. So we also have T1 minus, okay, plus T1 minus, okay, minus Ft, okay, minus T1 minus Ft, because that T1 is opposing the motion, as you can see, right? T1 is opposing the motion because it's pulling that 5 kg block downwards, okay, yes. So that's how it goes. So we have mass multiplied by acceleration. So what's our T2? Our T2 is equal to 250 newtons minus, what's our T1? Our T1 is unknown, minus, what's our gravity? So in order to calculate our gravity, we're going to say 5, okay. So I'm so sorry about this, guys. Fg is equal to mg. So your gravity is equal to 5 multiplied by 9,8. Let's press into our calculators. 5 multiplied by 9,8 is equals to 49. Okay, yes, this is equals to 49. So sorry, this is equals to 49 newtons. It's equals to 49 newtons. Okay, so we have negative 49 is equals to, that's our mass there, it's 5. Okay, yes, that's our solution. The solution is not given, 5a. Okay, yes, so 250 minus 49, let's press in our calculators. So 250 minus 49, so sorry, it's 201. Okay, yes, so meaning that 201 minus T1 is equal to 5a. Okay, yes, so this becomes our very first equation. Okay, so guys, that's how it goes. So let's go calculate for our 20 kg block. Okay, yes, okay, so this is now for the 20 kg block. This is now for the 20 kg block. Okay, so our net force is equal to MA. Okay, so net force, all the forces acting on that 20 kg block. Mind you, I said if you want to look what force is acting on that 20 kg block. Okay, yes, or I can say to you, yes, so 20 kg block, look there, you can see that there is a gravity that is acting on it downwards, and also there is a tension that is pulling it upwards, which is T1 at P. Yes, so there is T1 at P that is pulling it upwards. Okay, which is T1 is positive and our gravity is negative. Okay, yes, meaning that is opposing the motion. Okay, yes, so this becomes T1 minus gravity. Okay, yes, which is equals to 20 multiplied by 8. So what's our T1? Our T1 is unknown, minus what's our FG, the gravity for this 20 kg block. So FG is equal to mg is equal to 20 multiplied by 9,8. Let's go, 20 multiplied by 9,8. Let's press our calculators. So 20 multiplied by 9,8, and that gives us 196 newtons. It gives us 196 newtons, and so it goes. Okay, so now this becomes 196 newtons equals to 28. Okay, and this becomes our equation 2. Okay, yes, so this becomes our equation 2. So let's move to this side, guys, to continue with our calculations. Let's move to this side. Okay, so let's combine our equations and find the value of A. This is our solution. So this is equation 1, this is going to be equation 2. So equation 2, 1, it's 201 minus T1. Okay, and minus T1 is equal to 5A. So equation 2, T1 minus 196 is equal to 2A. Okay, yes, so this becomes 25A. This one cancels this one. Okay, yes, opposing each other, negative, and the positive coefficient, which is coefficient of 1, it's 0. So 201 minus 196. So let's press in our calculators, guys. 201 minus 196, this becomes 5. So our answer is 5. So our answer is 5. So over 25 over 25, therefore our A is equal to this. Okay, 5 divided by 25. Okay, so 5 divided by 25, this becomes 0.2 meters per second, 0.2 meters per second squared. Okay, that's how it goes. So they said you must calculate for the tension. Okay, so for you to know what the tension is, what you should do, you have to substitute in any of the equations our acceleration as our answer. So let's choose n. Okay, let's choose equation 2. So t1 minus 196 is equals to 20a, which is 0.2. So 20 multiplied by 0.2 multiplied by 0.2. Okay, 20 multiplied by 0.2 is 4. So in this side we have 4. Okay, is equals to t1 minus 196. So let's take 196 to that side. Okay, so if we take 196 to that side, therefore our t1 is equals to yes, our t1 is equals to that's 200, right? Yes, 196 plus 4, it's 200 newtons. That's how it goes. Yes, that's very correct, guys. So let's move to question 2.4. So question 2.4 says, when the 250 newtons force is replaced by a sharp pull on the string. Okay, yes. Okay, so when the 250 force is replaced by a sharp pull, okay, by a sharp pull on the string, one of the two strings will break. Okay, so the question is, which one of the two strings, P or Q, will break? So string Q will break. Okay, yes, this string will break if ever the 250 newton is replaced by a sharp pull. Okay, yes, it's being replaced by a sharp pull. This one will break. Okay, yes, so Q will break. So in answering question 2.4, Q will break. Okay, yes, you can say Q will break. Okay.